Alrighty. So I finally figure out, how to get this done. Um, so it's recording the right part of the screen, and I can alternate between um, the terminal and the browser now. Um, and also I can even display Logisim, when it's time to do it. So anyway, I got the program assembled, and it's not working, which is great because now I can debug it and show you how to debug a program that is not working. So we got the program. Let's get the program loaded here. Okay. And I didn't change the name, so it's just assembler RAM file. So we load the program. And to debug the program, we are going to use the logging ability. And let me show you the configuration. It put this window somewhere else on the screen so that you couldn't see it. So that's why I have to move it. So here's the program counter. Change the base to 16. We want to keep track of at least the stack pointer. So the stack pointer is in the register bank, and it is register D. And once again, we'll change the radix to base 16, so that's good. And then we also need to track quite a few locations on the stack. And we'll go to the RAM component, which is this one. And we're going to track location 255, 254, 253, 252, 251, 250. Okay, so I'm just counting the locations here. This is X, this is Y. This is the last parameter of the nested call. This is the last parameter of the, well, this is the last parameter of the outer call. This is the last parameter of the inner call. The second last and the first parameter of the inner call. This is going to be the return address of the inner call. This is going to be the two saved registers in the nested call. And then this location should not be used. So these are the locations that we are consuming on the stack. And we'll change the radix of everything because binary is really, really hard to see. Let me see if I can, nope, I cannot select a bunch and change them at the same time. So this is going to be a little bit tedious. Yeah, this program is not working, but so we'll use the trace ability to find out why it's not working. All right, there we go. So we got everything set up here. We can then close window. Oh, wait, one more thing. I want to log it to a file. So we have to go to file here and select a file. I'm going to put it into div.tsv in the temp folder. Okay, save. There we go. And then we can close window. And here's Control K. And you can see the program is definitely not stopping. So I'm gonna let it run up to this point, Control K, and go like, okay, this is definitely not working. So it's time for us to take a look at the program, go take a look at the trace and find out why it's not working. I can do that on the command line, but it's not going to be easy to read. So if I look at div.log on the command line, nope, change the name to tsv. You can see it's kind of difficult to read. So that's not the best way to do it. The best way to do it is to import it into a spreadsheet. So I'm gonna use a new spreadsheet here. And then we'll use the import feature, okay, to import a TSV or a tab separated value file. So we go to, oh, we have to go to upload and then go to my temp folder, locate div.tsv. Okay. And if we want to use a tab as a separator character, replace spreadsheet is fine. And then click import. Okay, so this, all right, so we'll rename these columns because this is our stack pointer, which is register D. And then this is location 255. And this is location, this one, -1. And so this way I don't have to retype, the same thing over and over again. Okay, so we got all the locations, and we'll shrink the column width so everything is on the same page. Excellent. All right, so we got this, and we definitely can tell that the program is not working. And when the program is not working, we're looking for signs that the program is not working. And we can see how it's using more and more space on the stack. And it is using the correct amount of stuff on the stack too. And then the other trick I have here is to use this little trick here. Pull this little line, divider line. So this way I can scroll the bottom part of the screen and making the top part stay stationary. So it's easier to kind of find out what's going on. And I'm not sure whether this is actually location 255. We're tracking the program counter. We're tracking the stack pointer. The stack pointer goes to FF, so that is correct. So 255 is, oh, okay, it is correct. So 255 is variable X. So I should probably comment here that 255 is actually, variable X. And then the next one is, oh, okay, it doesn't like that because this is 254, which is variable Y. It doesn't like it because the equation thing doesn't work anymore. And so we'll get rid of the equal sign and just type it to, this is 254, which is a variable Y. Okay, we are readjusting all of this stuff here. This is 253. So with these, we can just keep it the same, kind of the same as before. All right. So we got 255, which is uninitialized. And then we got 254, which is also uninitialized. And then this is the last parameter of the outer call. So let me describe which one we're talking about here. Where's my TTPASM file? There we go. All right, so we are setting up for the outer call. So the address of Y is going to be at the location 253. And location 253 has FE. FE is 254, which is the address of Y. So that got pushed correctly. And then we have a 0 pushed, and we can track the stack pointer, how the stack pointer is now pointing to FD. So FE is 254, FD is 253, FC is 252. And then we got this is the null address. This is 3, this is 15, and this is the return address. So after the return address is set up, we continue execution in the subroutine. That's why we see a jump from 1.8 to 2D. And 2D should be the entry point of the subroutine. We can double check that because we can go to source debug tab and basically go to that location. I cannot remember 2D. So we can go to location 2D, which is in column C. So location 2D is in fact the entry point of the subroutine here. So that part is correct. So we can double check and verify the program is working all the way up to here for sure. So once it gets here, it's going to go through some computation, which we cannot see because I did not track the other registers. But we would be able to see the side effects when we push the divid when we push the remainder and also the quotient on stack. So okay, so we got one of them pushed. There we go. So here we have the 5 push on stack. That is our divisor. No, I take it back. This is our quotient. The quotient is pushed on the stack. And because 15 divided by 3 has a remainder of 0, so that is not stored. So what we can see here is we should skip over the storing part of the subroutine. Okay, so when we keep going, this is the returning of the subroutine back to the caller. So the continuation point of the caller is 19, and we can check that too. So we can now go back to location 19. And in fact, location 19 is main return address 1. So it did return correctly to this location. And then we increment D, decrement D, and then store A. So we should be pushing 5 on stack at that point. Okay, so let's check that. So back to main, we have increment. So you can see how the stack pointer got incremented from FA to FB, FB to FC, and then FC to FD. And then we decremented one more time in order to store that quotient on stack. Now, unfortunately, in this case, the quotient is taking, no, the quotient should be visible. The quotient should be stored at location FC, which is 252. And there we go. So we got that, stored here. So now we are setting up the call. This is the outer call where 7 is the dividend, 5 is the divisor, FD is the address of the remainder. So it all got set up correctly. And then we call the subroutine, which means we should see a jump of execution address. And we did not. Okay. Okay, so the question is, did we set up the return address correctly? Okay. So we got everything here set up, and then the return address is not set up correctly. That is why. Okay. So now we kind of know what the problem is because, oh, okay, I see it. Okay, look at this line here. On line row 34, I put the return address into register A, and then I immediately jump into the subroutine, which means return address is not pushed on stack. It is put into a register, but it was never pushed on the stack, and that's why it didn't know how to return. Well, I shouldn't say it didn't know how to return, but it did not return to the right place, because what it did instead, if we look at the spreadsheet here, so what it did instead is it would use this location as the return address. No, it returned to location 7 because I didn't push the return address at all. So that means the last item pushed is mistakenly understood as the return address. In other words, we should see at some point a continuous execution at location 7, and here it is. So that confirms my observation. All right, so we have a bug to fix, no big deal. And this is the program here. And the bug is at this point, I store the return address into register A, but then I forgot to decrement the stack pointer and then also store the return address on stack. So that is what I missed. I forgot to do. So now we'll go ahead and copy this program to the assembler source tab. Okay, paste right there. Got to make sure the computation is done. It's calculating. It would be nice if I can change that caption to say assembling, because that's exactly what it's doing. It's assembling. We go to the RAM file, download as CSV. Okay. And it is downloaded as the one with the parentheses of 1. Not sure whether Logisim can take it or not. We'll find out. So get back to Logisim, reset Logisim, and then we'll load image. And this time we'll use the one with parentheses of 1. Click open. Yep, it like that. Control K. Oh, Control K doesn't work because I forgot there's a bug in Logisim where once we log the file like this, it basically stops working. So we have to start it again. Okay, there we go. Then we right click, load image, same thing. Go to, we're already in the right folder and we want to pick up this file. There we go. All right, so we have to set up all the logging again. Or we don't have to because the trace is in the memory itself as well. So we'll do Control K and it's all done. And now we examine the RAM content. Let me go to the RAM content here. There we go. So let's see whether this is all done correctly or not. So we are reading from the last location and backwards. This is X, and this is Y. Okay, doesn't seem right to me because 7 divided by 5 should be a 1 with 2 as a remainder, and we can see the 2 here, but it's not stored over here, so something else is still not correct. Okay, let's check out the source file. So the last byte on stack is X. And when we are supposed to storing it back to X, storing the quotient back to X, we are storing it to Y. So the stack is 1 byte off because this instruction, which is supposed to be storing 7 divided by 5, or the quotient of that, is actually storing it at the wrong location. And then the remainder of 7 divided by 5, which is 2, is also not stored correctly. Okay. So that means we have to debug this a little bit more. Okay. Okay, so let's reset it first. And then load the image again. And then we'll set up to trace it. It's just that every time we trace, we can't come back and continue the program later on. So it's just gonna be a hassle. So we need the program counter. We need some of the registers. So we'll track register D, which is our stack pointer. And then we'll track, and then we want to track certain locations in RAM, the last few locations. So we go to RAM. And we want to track location 255, 254, 253, 252, 251. Okay, those are the locations, and then we have to change the radix of all of these. Okay. Unfortunately, there doesn't seem to be a way to set a default. You can definitely tell that debugging is not easy when you don't have a debugger. But being able to track down the registers and whatnot is already a big help. All right, so we also want to save everything into a file. So we go here, select, we'll go back to and put it into div.tsv and overwrite the file. There we go. All right, so let's go ahead and Control K until it gets to the halt instruction. Now we can import that into the spreadsheet again. So we'll import, because every time we import, we can replace the sheet itself, which means we don't have to create a new file. So this is div.tsv. Yep, there we go. All right, create new sheet, replace spreadsheet, and tab is the separator. Okay, we'll just re-import. All right, there we go. And as before, we change this to stack pointer. This is X, this is Y. This is supposed to be the address of Y. And this location changes the purpose depending on what time we are talking about. In the nested call, this position is the null address, but in the outer call, this becomes it becomes the divisor, which is 5. Okay. This one is also dual purpose in the nested call, in the outer call, this is our dividend, which is 7. But in the nested call, this is our okay, let me think about this again. Okay, no. And we have 7. Nope. Okay, this is in the nested call. In the nested call, this is 3. In the outer call, this becomes 5. And then with this location in the outer call, in the nested call, it is 15. In the outer call, it is 7. And then the other locations, basically they become the return address and stuff like that. So we'll take a quick look at the code here, and we can definitely see how the 2 came about right about here. Okay. And then we can find out what address is responsible for that. It's 42 or 42 in hexadecimal. We go back to the source debug tab and we locate location 42. And location 42, that doesn't make sense. There are no store instructions here. Okay, something is amiss. Okay, let's make sure the program does end at the right place. The last instruction it executes is location 2F. And location 2F is indeed the halt instruction, or the one byte before 2F is the halt instruction. So it did end at the right place. But it is storing a 2 at the wrong time. This row here is storing a value of 2 on the stack. And the address of the program counter corresponding to that is 4-1. Okay, location 4-1. And according to this, at location 4-1, okay, so it is 4-0 that stores it. So it is pushing the remainder. So the remainder was pushed correctly, but it was not. So if the remainder is pushed correctly, but it was not stored in the location, Y never got that value because Y is column D. Column D. Oh no, column D got changed to 2, so that's good. Okay. But then we are also storing the 1. We are overwriting Y with 1, so that means we're only off by 1 when we need to store X. Okay, so that means the stack is not balanced. 3 increments to take care of the 3 parameters. We push the second argument, we push the first argument, we push the return address on the stack, we call the subroutine, we come back, we pop the parameters. So that D would be pointing to Y at this point. Okay, I got it. This one is supposed to be increment C and not increment D. That's the only mistake left. Okay, so let me just explain that one more time. I know this is confusing. Um, um, C is a copy of D because of the CPR instruction. And at this point, D, which is the stack pointer, does point to Y because we have everything else deallocated already. So C would point to Y as well because of that. But I used the incorrect increment here because I incremented D instead of C. And because of that mistake, C would still be pointing to register, not register, but local variable Y when we store it. So that's why we had a problem. Okay, after this is all done, I'm missing 2 increment instructions here because these 2 are here to deallocate. This one deallocates Y, and this one deallocates X. Okay, so now the program is correct. Obviously you cannot see what I was talking about. Okay, because I forgot to put the window over here. So the problem had to do with these 3 instructions. Originally, I put a D here instead of a C. So when I store the return value, I store it at the wrong place. I also added these 2 increment instructions to deallocate X and deallocate Y. It doesn't really matter all that much because the halt instruction is right after the increment instruction, but from the perspective of balancing the stack, this still matters. So what I'll do now is I'm going to upload this particular program. Okay, save it first, and then I'll just upload to Canvas so that you guys have access to it. You can use it for studying, or you can just ignore it completely. Just keep in mind that this may or may not be related to the exam. So I'll go ahead and put it in here. We'll just add a file. And it's a new file. Browse. It's going to be in my temp folder. Calendar, temp. So this is in temp div sub.ttpasm. Add item. Now it should be there. Yep. So the solution to the homework assignment is here. You might want to take a look because it is the answer. And also the whole debugging process, might be useful as well. Alrighty. So I'm gonna sign off now. Okay. I hope you guys have a nice weekend. I'll see you guys on Monday. If you have any questions, please bring those questions on Monday.